There's a few formulas you need to know, which involve sine, cos, and tan, which are known as addition formulae. Now, these formulas have a plus format and a minus format. So what I'm going to teach you is the addition formulae, but I'm going to write the plus and minus at the same time. So I'm going to use this notation, plus minus, okay? The first formula you need to know involves sine. So sine bracket a plus b. This is the format of your formula. So you could have something like sine x plus y, for instance. What the addition formula allows you to do is expand that bracket. It's going to be different to expanding just any regular bracket because now you have a trig function and things work slightly differently with a trig function. So with this, your expansion essentially will be sine A cos B plus cos A sine B. The plus minus will look like this. So when the bracket, or when the sign inside the bracket is negative, the sign outside the bracket on the right hand side will also be negative. If it's positive inside the bracket, it's positive outside the bracket on the right hand side. Okay? So in this case, it would be the same as sine x cos y plus cos x sine y. Let's say if inside the bracket it was negative, then it would also be negative here. Okay, that's addition formula number 1. Addition formula number 2 is for cos. So cos A plus minus B. The right hand side will look like this. Cos A cos B and then minus plus. Sine A sine B. This means when inside the bracket you have a plus, outside the bracket you're going to have a minus. If inside the bracket you have a minus, outside the bracket you're going to have a plus. Okay, the last one. Tan A plus B. Sorry, A plus minus B. You're going to have tan A plus minus tan B all over 1 minus plus tan A tan B. The textbook, the official Edexcel textbook, has those split up. So where I've written plus minus at the same time, they instead of having 3 formulas, they have essentially 6. But 3 is always going to be easier to remember. It's just a matter of remembering the plus minus and the orientation. With enough practice, you're going to get there. I would suggest every time you use any identity or any formula, write out the actual formula before you use it. And you're going to find that it's going to stick a lot better. Okay, so let's have a look at an example which applies the addition formula. So you got to prove that the left-hand side equals the right-hand side. Let's start with the left and let's go to the right. The first step would be to make those 2 fractions into one large fraction, right? How would you do that? The lowest common multiple, or your denominator, ideally would be sine B cos B. And then sine B cos B. In order to do that, you need to times this cos A by cos B. And then that sine A by sine B. That's the only way you can combine the two fractions. So cos A cos B minus sine A sine B all over sine B cos B. Using our cos additional formula, cos A plus minus B is the same as cos A cos B minus plus sine A sine B. Which means if on the outside we have a negative, on the inside of our bracket we're going to have a plus. That can be applied to our numerator. If you notice, it's got the same format as our right hand side of the addition formula with a negative, which means if we put it into brackets, it's going to be a bracket with a positive. So this becomes cos A plus B all over sine B cos B. And there we go. That's our right hand side. So we've proved it. Okay, let's have a look at another example. With this one, we're now going to make use of tan because we want express tan x in terms of tan y. So you can already imagine we're going to incorporate the tan addition formula. Most likely, we don't know exactly, but I'm just going to keep that at the back of my mind. Preparing myself, okay, I'm probably going to have to use it. Given that 2 sine x plus y is equal to 3 cos x minus y. In this case, you want to use the addition formula for both cos and for sine. Because there's a 2 in front, I'm going to use a square bracket. And when I expand, I get this. Yeah? Equals 3, another square bracket, and now we're going to do the cos one. Cos x, cos y. Inside the bracket is a negative, so outside the bracket is going to be positive. Sin x, sin y. Now, expanding the 2 and the 3 gives this. Sorry, this takes a long time to write. Oh. Sin y. There we go. Okay. From here, we want tans. We want tan x. We want tan y. So what can we do in order to convert all our sines and coses into tan x's and tan y's? You can divide each term by cos x, cos y. Okay? By doing that, you are going to cancel out any of the cos y's, you're going to cancel out any of the cos x's, and you're going to produce tans because your numerators all have sines. That sounded really confusing, didn't it? Let me explain. On the first fraction, we've got cos y at the top and at the bottom. They both cancel. We've got sin x at the top, we've got cos x at the bottom. That leaves us with 2 tan x. Okay, with the second one, we've got cos x on both the top and the bottom. Our sine y over cos y produces 2 tan y. Do you see how by dividing by cos x cos y, we're eliminating the causes and we're producing tans? Okay, so for the next one, the third fraction, what would you get? You would just get 3, because these two cancel and these two cancel. And then finally, for the last one, you would get 3 tan x tan y. Okay, last bit, express tan x in terms of tan y. So now you're trying to get tan x as the subject of your formula. So can you try that for me, please? So what I'm going to do is I'm going to put all the tan x's on one side. Like this. And then factorize out tan x. And then divide by the bracket. There you go. You've now expressed tan x in terms of tan y. Done. Quite long, hopefully not too confusing. You might be wondering, yeah, but I would never know to divide by cos x cos y in this step, which is fair enough. I probably wouldn't have thought to do it either, but it comes with practice. With enough practice, you're gonna figure out, okay, what to do when. Not every time though. It is sometimes gonna take a little bit of guesswork. It's gonna take a bit of, shall I say, calculated guesswork. But it does come with practice. So you have to be patient with yourself. You have to be persistent when you're doing these questions and really trying to understand why they've done what they've done. They can only change the question so much. Okay, so if you've done enough questions and you understand why, then you're going to figure out when you see something arguably new, you know, okay, I've done these questions, I have an idea of what I can do. Okay, I've put up question 7. I'm just going to make more space for myself. Question 7. Can you please give that a shot? Okay, this one isn't so bad. You need to use the sine addition formula. The sine addition formula looks like this. And now, applying that where a is x and b is pi over 6, you would get sine x cos pi over 6 plus cos x sine pi over 6. And now it's just a matter of plugging in cos pi over 6 and sine pi over 6 and then multiplying. So cos pi over 6 gives root 3 over 2. And then you write the sine x. Sine pi over 6 gives a half. And then you write the cos x. There you go, done. That's it. You can't go any further. That's as simplified as it gets. Okay. Can you try question 15 for me, please? In this one, you're using the tan addition formula. The tan addition formula looks something like this. Where your A is x and your B is pi over 3. So plugging it in, you should get this. There we go. And then all of this equals a half. Okay, plugging in tan pi over 3 into the calculator, tan pi over 3 is just root 3. This equals a half. Now you can cross multiply. So 2 tan x plus 2 root 3 equals 1 minus root 3 tan x. Okay? Grouping all the tan x's together will give this, 1 minus 2 root 3. Factorize out tan x. Like that. Let me write it like this, just so it's not confusing. And now you can divide by 1 minus 2 root 3 over 2 plus root 3, like this. Is it finished from here though? No, because you have a surd at the bottom. You need to rationalize it. After rationalizing the surd, you get 8 minus 5 root 3. So from here to here, you want to rationalize. And then you've shown it. There you go. That is the addition formulae.